exactly attraction type instrument? What is the operation of attraction type instrument? And I given some points with respect to attraction type instruments. Okay. Now we'll see what exactly repulsion type instruments. Yes. Whatever the points already list out in attraction type instrument, the same points is applicable for repulsion type instrument also. Okay, that point to remember. But here we'll see what is the difference in operation of attraction and repulsion type instrument. But I told already, in repulsion type instruments, again there is two types of instruments. One is radial vane. Radial vane. This is classification based on the shape of iron piece we are using. That is radial vane instrument, repulsion type instrument. Another one is coaxial vane. Coaxial vane. These are the two instruments we are using, radial vane and coaxial vane. Okay. Now see, the radial vane means the shape of iron piece we are using like this. Iron strips we can use. If you use this type of iron pieces, then it is nothing but a radial vane. Coaxial vane means coaxial, this is the shape of iron piece. It's just like cylindrical sections. These are sections of cylindrical. If you use this type of iron piece, then it is nothing but a coaxial vane. Okay. But as compared to radial vane, in coaxial vane, based on this shape, it provides more uniform magnetic field as compared to radial vane around the moving system. It provides more uniform magnetic field as compared to, because of this radial vane shape, the wave that magnetic field becomes more uniform as compared to radial vane type. Now see, here I am drawing this repulsion type instrument using radial vane. Okay, that you will see. First draw the construction details of radial vane type instrument. This is the repulsion type instrument. It also consists of electromagnet. Yes, parallel you draw this, don't wait. It also consists of electromagnet. But the shape of electromagnet is, we can use I-shaped magnet. But you seen that in the case of attraction type instrument, the shape of the magnet is H-shaped magnet. Here we are using I-shaped magnet. I-shaped magnet we can use. Parallelly draw this. This is electromagnet representation. Yes. You draw this electromagnet. Yes. Here we are placing, this is winding representation. Okay. This I am representing is current entering and leaving. That is, current is enter in winding and leaving in winding. Yes. This current entering cross. This current leaving is dot. Yes. Then we can make spindle arrangement. Yes. This jewel bearing suspension. The purpose of jewel bearing suspension I already explained. This reduces frictional errors. Okay. Then we are using spring control. And we are using air friction damping. Yes. This is pointer and scale arrangement. Yes, this is theta deflection, the deflecting torque. When our deflecting torque equal to controlling torque, and the pointer comes to the steady state. Okay. Then there is a two iron pieces. We are arranging like this. These two are iron pieces. One is a fixed vane and other one is movable vane. Yes, this iron piece is movable. This is fixed vane. Fixed iron piece. And this is movable vane. Movable vane. Okay, and this is electromagnet. 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 Okay, and this is jewel bearing suspension. Yes, jewel bearing suspension. Then this total mechanism put in this box. Just for understanding, I am giving this box. Then it becomes a moving iron repulsion type instrument. Yes, then this is the connection. We are connecting to the supply. This is the direction of current. Yes. Whenever supply is switch on, then current is flowing like this. This is the flow of current. This is the direction of flow of current. Okay. Entering and leaving. Okay. This is about what exactly a repulsion type instrument. Yes. But here the shape of iron pieces we are using is radial vane. That's why it is a radial vane repulsion. If you use coaxial vane means, I'm not drawing total arrangement like this, you remember. This is coil. This you are drawing as a coaxial vane type. Yes. This is coil. Yes. And we are placing one iron piece like this. This is the coaxial vane. The iron piece is like this. This is coaxial vane repulsion type instrument. Okay. Now tell me, what is the operation of either repulsion, that is radial vane type, or it may be coaxial vane type? Whenever supply is switch on, yes, whenever supply is switch on, this electromagnet will be magnetized. This I am representing like this. You know this. This is one representation of electromagnet. This is I-shaped electromagnet. I am representing like this. Okay. Dot cross, entering, leaving. Current entering, leaving, entering, leaving. Like this we are representing. Yes. Whenever supply is given, it may be AC or DC. I told already. Either AC supply is given or DC supply is given, the electromagnet will be magnetized. Here also, whenever supply is switch on, the electromagnet will be magnetized. Once electromagnet is magnetized, but point to remember, the difference in the placement of iron pieces in the case of attraction and repulsion type instrument is, in the case of attraction type instrument, this is electromagnet and this is the iron piece. This iron piece is outside the magnetic field. But in this repulsion type instrument, these are placed within the magnetic field. Whenever iron pieces are placed in the same magnetic field, and those two iron pieces are magnetized in the same direction with the same poles. Magnetized in the same poles means, if it is north pole means it is also north pole, it is south pole means it is also south pole. Like this it will magnetize based on the direction of current. Okay, then that means both the iron pieces are magnetized with the same poles, and this is fixed vein attached to the hollow cylinder, and this is the movable vein attached to the spindle. Understood? It is fixed to the hollow cylindrical arrangement, and this is, but this movable vein is fixed to the spindle. Okay, that means whenever supply is given, these two iron pieces are magnetized in the same direction. Whenever two iron pieces are magnetized in the same direction in the sense with the same poles, south south, north north. For example, it is north, it is also north, then it is south, it is south. Then because of similar poles, now it is acting as a one magnet, it is also acting as a one magnet. Because of similar poles, there exists a attraction force between these two iron pieces. Okay, but this iron piece is fixed to cylinder, hollow cylinder, but it is fixed to spindle. Because it is fixed to hollow cylinder, then whenever, and it is fixed to spindle now, let us assume that these two are the iron pieces. These two iron pieces are magnetized in the same direction. But whenever these two are magnetized in the same direction, because of similar poles, a repulsive force exists. Because of this repulsive force, this iron piece will not repel like this and move like this. It cannot move like that. Why? Because it is fixed to the spindle. That means there exists a repulsive force, but this iron piece will not completely repel and is not moving out of this one. Understood? But because of that force, but it is not moving, but it is not repel and is not move out of this. Then, but there exists a which force? Repulsive force exists. Because of that repulsive force, finally what happened? That repulsive force is acting as a twisting force on this iron piece. That is, whenever that repulsive force has a twisting force on the iron piece, then iron piece will rotate like this. This radial vein iron piece, this is the radial vein. This iron piece will rotating like this. This iron piece is rotating like this because of this repulsive force. Whenever this iron piece is rotating like this, along with iron piece, the spindle is also rotate. When the spindle is rotating, then along with the spindle, pointer is moving on the scale. Whenever pointer is moving on the scale, because of elasticity property of spring, the spring is wound in opposite direction. Then whenever deflecting torque equal to controlling torque, then the pointer will comes to the steady state, then meter shows the required reading. Understood? Concept very simple. Whenever supply is switch on, the electromagnet will be magnetized because of two iron pieces are placed in the same magnetic field. These two iron pieces are magnetized with the same poles. Because of these two iron pieces are magnetized with the same poles, a repulsive force exists between the two iron pieces. One is fixed to the cylinder, another one is fixed to the spindle, movable part. A spindle is the movable part. Because it is fixed to the spindle, due to repulsive force, a twisting force is produced on the movable vein, then the movable vein is rotating. Once the movable vein is rotating, then whatever the spindle is also rotate. When the spindle is rotating, then pointer is moving on the scale. When the pointer is moving on the scale, then the spring is wound in opposite direction. Whenever deflecting torque equal to controlling torque, then the pointer will comes to the steady state. Okay, this is the operation of repulsion type instrument. It is a radial vein type. Here the principle is based on which one? A repulsive force. But in the case of attraction type instrument, always the force between electromagnet and iron piece is which force? Attraction force. That's why that will work on the attraction principle, but it is working on the repulsion principle. Even in the coaxial vein type instrument also same principle. These two are placed in the same magnetic field. Whenever these two are placed in the same magnetic field, then these two iron pieces are magnetized. Magnetized in the same direction means it is north pole, it is also north pole. It is south pole means it is also south pole. Like that it is magnetized in the same poles. Whenever it is magnetized in the same poles, this iron piece will be repelled from this one because it is a fixed vein. This is the fixed vein. Okay, and this is the movable vein. This is the movable vein. Then this is repelled from this iron piece. Whenever it is repelled from this iron piece, then this iron piece is moving like this now. Once the iron piece is moving like this, the pointer is also moving like this. Whenever iron piece is moving, the pointer is also moving. Then spring is wound in opposite direction. Spring is wound in opposite direction. Then whenever deflecting torque equal to controlling torque, then the pointer will comes to the, whenever deflecting torque equal to controlling torque, then the pointer comes to the steady state. Okay, this is the operation of coaxial wave. The only difference is here the shape of iron pieces are different. Understood? Okay. Okay, this is the operation of what exactly a repulsion type instrument. Okay. Okay, these remaining points. What is the purpose of using jewel bearing suspension? To reduce the frictional errors. How the deflecting torque is produced? Based on magnetic effect, electromagnetic effect. What type of controlling torque we can use? Spring controlling torque we can use. What type of damping you can use? Air friction damping, because the coil is not a iron core coil, not a iron core, not a steel core coil, it is air core coil. Once we can use air core coil, what is the purpose of using air core coil? Because already we are using iron pieces. Because of that iron pieces, we can get more hysteresis and eddy current losses. To reduce that only, we are using air core coils. Once we can use air core coils, the flux flowing is less. That's why very weak magnetic field is produced. That's the reason why in the case of, it may be attraction or repulsion type instrument, what type of damping you can use? Air friction damping you can use. And these are also used for both AC and DC. No doubt at all. These are also used for both AC and DC. Then if any supply is given to the moving iron, it may be repulsion or it may be attraction type, it is a RMS measuring and RMS indicating type instrument. Whatever the input we can apply to the moving iron instrument, it measures which value, RMS value it measures, and it indicates the RMS value. Then once we are using for AC means we are also consider frequency. Then these are used for a frequency of 0 to 125 Hz, and these are also unpolarized instrument. We can give the AC supply or DC supply, whatever may be. For AC supply or DC supply, always force is in one direction, torque is also in one direction. Whenever deflecting torque equal to controlling torque, then the pointer comes to the steady state. But one point to remember here, sir, for AC supply is also torque is in one direction. For DC supply also torque is in one direction. But in the representation, for example, once I am using this instrument for AC, then in the representation of meter, let this is MI meter movement, this is MI meter movement, RM is the meter resistance, LM is the meter inductance. For AC supply, you take like this, for AC. Then for AC, what is the equivalent impedance you tell me? Equivalent impedance equals square root of RM square plus omega LM whole square. This is meter impedance for AC supply. If the same instrument is used for DC, if the same instrument is used for DC, this is MI meter moment, it may be attraction or repulsion, same concept. And this is the meter resistance and this is the meter inductance. For DC supply, for DC, what the reactance offered by this equal to 0, that's why don't consider LM. Then what is the ZM equal to? The ZM equal to RM only. That is the only difference you take. If the instrument is using for AC means you consider the inductance also, because it offers the inductance. Already in the attraction type instrument also, I told always the iron piece will align in the direction of high inductance. That's why it is not a negligible inductance. That's why it offers the high inductance. That's the reason why once we are using for AC means you consider the impedance. Once we are using for DC means you consider the resistance. That is the only difference once we are applying for AC supply and DC supply. Remaining concept is same. Understood? For DC you consider only resistance. For AC you consider the impedance. Okay. This about what exactly attraction type and repulsion. But one point to remember, as compared to radial vein and coaxial vein, this coaxial vein is more sensitive. Coaxial vein is high sensitivity, as compared to as compared to radial vane type. Radial vane. Because of shape of iron piece as compared to radial vane. This instrument is having high sensitivity as compared to radial vane. The principle is same, but that is the high sensitivity. Okay. This about what exactly the operation of repulsion type instrument. But the points, whatever the points I list out in the case of attraction type instrument, same points it is applicable, only operation is different. Now I want to give what are the differences between attraction and repulsion type instrument. You write attraction, in one side you write attraction type instrument. What are the differences between attraction and repulsion type instrument? Attraction type instrument. In another side you write repulsion type instrument. Repulsion type, important for theory questions. Repulsion type instrument. If we compare attraction and repulsion type instrument, listen please. What is the shape of magnet we are using in attraction type instrument? I-shaped magnet is used. Yes, I-shaped magnet is used. I-shaped magnet is used. What the shape of repulsion type? Sorry, this is H-shaped. But in the case of repulsion type instrument, I-shaped magnet is used. Yes, I-shaped magnet is used. Then this attraction type instruments are having less inductance. Having, yes, less inductance. And it is made with high inductance. It offers high inductance. High inductance. Okay. Then one more point to remember. This is more accurate. More accurate. But the repulsion type instruments are less accurate. These are less accurate. Then this attraction type instruments is high cost, and this repulsion type instruments are less cost. Then this is less economical. Sorry, this is less economical. This is more economical. Because of less cost, this is more preferable. Practically more preferable. And these instruments are less preferable. Because of cost point of view only I am giving this. This is more preferable and this is less preferable. Okay, this about what are the differences between attraction type and repulsion type instrument. Okay. And this, what is the operation of repulsion type instrument? What is the operation of attraction type instrument? I already explained. But one point to remember, based on the what is the direction of the flux in this. For example, this is the coil is there and this coil is flowing the current like this. Current is entering like this. The direction of flux is determined by using right hand thumb rule only. Okay, this is the current direction means this indicate the, this is current direction means this indicate the flux direction. Okay, how to apply right hand thumb rule you know. Okay, but it is based on the type of conductor. If it is a straight conductor or it may be solenoid conductor. But here what is the conductor is nothing but a solenoid conductor. In the solenoid conductor, that means the conductor is like this. It is a solenoid conductor. If the solenoid conductor means just like in transformer, then curled fingers indicate the current direction, thumb indicates the flux direction. If it is straight conductor means exactly opposite. Thumb indicates the current direction, curled fingers indicate the flux direction. By using this right hand thumb rule only, we can find the what is the direction of flux in a moving iron instrument. Then, but one point to remember, in the representation of PMMC instrument, I am not consider any inductance. Why? Because where completely it is used for DC. But here I am considering the inductance also. But when you can consider the inductance, if it is used for AC, if it is same instrument can also be used for DC also. But the same MI instrument once we are using for DC means in the calculation of current or in the calculation of impedance, you don't consider the inductance with respect to DC. With respect to AC only you can consider. Okay, this about in detail what is the operation and construction details of moving iron instruments. Okay, these moving iron instruments are having the high power consumption, no doubt at all. One of the main advantages of moving iron instruments are less cost. I'm talking about not with respect to attraction and repulsion. Okay, in general I am talking as compared to any another instrument, these instruments are less cost, but the power consumption is also more, no doubt at all. But because of less cost, these instruments are more preferable practically for measurement of AC voltage and current. For measurement of AC voltage and current, which instruments are more preferable means MI instruments are more preferable, and these instruments are having high overload capacity also. Okay, it can withstand the high currents also. Even high currents are flowing through the instrument, then it can withstand the high currents. And these instruments are more preferable as an indicating type instrument. Moving iron instruments are used as a indicating type instrument only. Okay, these are not the integrating type instrument, these are not the recording type instrument. Mainly moving iron type instruments are indicating type instrument. Then if these instruments are mainly what type of control we can use? Spring control we can use. Mainly we are using the spring control and we can use the air friction damping. But same moving iron instrument is also used as a panel mounted instrument, means vertically mounted instrument. If these moving iron instruments are used as a panel mounted instrument, then we can use the gravity control. Generally, if it is not mentioned that it is a panel mounted, vertically mounted, like that it is not mentioned. Generally, what is the answer? In moving iron instruments, we can use the spring control. If the moving iron instruments are used as a panel mounted instrument, then what is the controlling torque we are using? Gravity control you can use. Like that you can concentrate. Okay, this is about with respect to construction details and operation, attraction and repulsion. Then the next session we will continue with what the deflecting torque equation of moving iron instrument. Okay, there is a pointer is moving now. In attraction type instrument also pointer is moving. In repulsion type instrument is also pointer is moving. Pointer is moving means because of the torque only. Okay, then what is the torque equation? I want deflecting torque equation. What is the observation from the torque equation of moving iron instrument? That is important for competitive point of view. Clear? Up to now I explained only theory point with respect to moving iron instruments. But one statement is important. It may be attraction or repulsion. Whatever the input is applied to, then what value it is measured? RMS value. Based on that statement also we can solve some question in classroom workbook. Clear? Concentrate.